Okay, this is part 3 of the 4-2 solving systems of equations by substitution notes. In this example, we're going to look at systems of equations with infinitely many solutions or no solution. So let's look at example A. What is a solution to the system of equations? Just like in example number 1, we're going to identify the equation that already has a variable isolated, and we see that it's this first one right here. Y is already isolated. We are going to substitute in for y into our second equation. So we have 6x minus 2 times whatever y is equal to a negative 2. So we are going to substitute in 3x plus 1 in for y. And of course, we do distributive property before we start combining like terms. I'm going to bring down my 6x term. Negative 2 times negative 3x is negative 6x. Negative 2 times 1 is negative 2, and that is equal to a negative 2. I notice that if I combine these two, since one is positive and one's negative, those two terms cancel out, and we are left with negative 2 is equal to negative 2. Since a negative 2 equals a negative 2, this is a true statement. This means that we have infinitely many solutions. This means we can replace the x or the y with any value and it will always be true. And if I would graph these represent the same line, therefore it has infinitely many solutions. So let's check our B. On B, we should notice that the second equation is the one that already has a variable isolated. Y is equal to 5x minus 4. So we are going to substitute in for y again. So I have 5x minus whatever the value of y is equal to a negative 4. So we're going to substitute in 5x minus 4. Because I'm subtracting all of this, I can actually put in a 1 here for distributive property. And we're really distributing the negative. So I'm going to bring down my first term, which is 5x. Negative 1 times 5 is negative 5x. Negative 1 times a negative 4 is a positive 4, and that is equal to negative 4. If I look at combining like terms, I have those two, which are inverses of each other. They cancel out. So I have 4 is equal to a negative 4. Since these two values are not equal, this is a false statement. This would be an example of no solution. So go ahead and do the try-its. Which equation already has a variable isolated? Keep that in mind. At the end, you want to review your notes and double check to see if you were correct.